All right, sixth graders, here is lesson 19, and hopefully I'll be able to wrap this up in about 10 minutes here. Okay, so as you can see from the heading, which I'm going to move in a second, we're kind of looking at unit price and related metric or measurement conversions. And really, it's kind of, this lesson kind of compares a bunch of different things. As it says on the top here, we're going to be looking at graphs, equations, to compare rates, and I might even add like looking at tables as well. Okay, so this initial exercise in here is just to see how you can create, from a ratio, and which I'll add in here. From a ratio, you can get an equation. From a ratio, you can also generate a table of data. Okay, so the first question is about these cups. We got blue cups and red ones, and our ratio is 1 to 2. Okay, so just to make sure you read it carefully, you got a blue here, you got a red, so you can put a B for blue and an R for red, just to kind of like keep track of what's going on. And then if we're going to fill out the table, which is going to say down here, make a table of values. Usually what we do in these tables is the first quantity is usually, the first number in the ratio, so I'll put blue here. And the second one will be the red. And maybe I should write in red and blue, but that's going to take me... All right, I'll do it now. All right, here we go. So for red, it is 2. Okay, and then for blue, it's 1. Okay, so if I try to extend this across and create more table values, remember going across in a table like this, we can just kind of add numbers, right? So start with 1 to 2, and then we got 2 to something, 3 to something, 4 to something. And then afterwards, to create the second line here, we just kind of follow the pattern. So this increases by 1, and to get the lower value, it's always twice as much. So that's going to be times 2 working down. This is going to be 3 and 6, and 4 to 8. Now, the interesting thing they do in here is they say this can be also represented in an equation. So they said red equals 2 times blue. So I'm just going to underline and put that in a box. Okay, so we were talking about this a little bit today and yesterday about how we can create these equations, okay? And they start with words, but then they always simplify to letters, okay? So red being R and blue being blue. Oops. Sorry, blue being blue. I mean blue being B, okay? So I'll kind of write that in there, okay? So there is our equation, which started from a ratio, okay? And which can be used to create a table of values. Okay, so R equals 2B. Okay, so this is my equation, R equals 2B. I'll write it on the left, and we can just test it. If I wanted to say, well, what happens if I have, say 10 blue balls, then I can just take 2, multiply it by 10, and that's gonna tell me the number of red. So that red is going to be 20. Okay? So that's the good thing about an equation. That's why we like equations, because once we generate an equation, we can apply the ratio to any number that we can think of that fits a situation we're dealing with. Okay, on the bottom here, we're kind of doing the same thing as the previous one, but now, as you can see here, we're not getting a ratio of 2 to 1 or anything like this. Now what's written for us is this question about a librarian, okay, who likes reading. Ms. Sipple likes reading, and she can read 3/4 of a book in 1 day. Okay, so again, we did this yesterday, so we could write this in a rate form. It could be 3/4 of a book per day, and per 1 day, and I'll just put the 1 in there just this time. Or you could say, okay, that's also like saying 3 books over 4 days. Okay, so those are actually the same rate, okay, but one is a unit rate. Okay, so then what we got here is they're kind of doing the same thing, is they're taking that rate and they're converting it over to an equation. So if D represents the number of days, then the equation is D equals 3/4 times B, where B, okay, is the number of books. Okay, so I'm going to do the same thing as I did on the other example. First, I'm actually going to fill in the table, and then I will look at how the equation matches the table. Okay, so again, in the table of values, you can kind of follow, it's a little bit different when you get a rate, because oftentimes the second value actually goes first in the table. Okay, so I'm actually going to put the day here, even though it was the second quantity mentioned. So it's like books in one day. Okay, and this one here is going to be books. All right, and you're going to see why in a minute. So day 1, okay, day 2, day 3, day 4. Now, if I work with the unit rate, I can see that it's 3/4 of book per 1 day. So then I could put 3/4 in this cell in the table. And because I know the unit rate over 2 days, then I can just double 3/4. So 3/4 times 2, and that's going to get me 6/4, which is 1 1/2. Okay, and I keep following that process going through. So add another 3/4. This is going to be 2 1/4. Add 3/4 to 2 1/4, and that's going to be 3. Okay, so that's filling out the table, and we can kind of rationalize it out, kind of like we did in the previous one. Now, the other thing that's going on is this equation, which I kind of underlined again. So D equals 3/4 of B. Okay, so how do we get this? You just kind of have to notice a pattern in here, right? So if you look at the rate is written as 3/4 of a book per day. Okay, so in creating an equation, what do we notice? Okay, so the 3/4 is going to be a multiplier in this equation. Okay, so that is actually like the unit rate. Okay, so the unit rate, whatever it is, okay, that is a multiplier. Okay, and then we have the D, which represents days, and B, which represents books. Okay, so what do we notice about where the books is? Books is in the numerator, right, on the top here. So 3/4 of a book per day. So you notice that that stays with the 3/4 unit rate. So you get 3/4 of times B. That actually means multiply. And then on the other side, you get equals days. So the other rate unit, day, I'm going to circle it. You can see that that goes on the other side when we're creating this equation from the unit rate. Okay, so that's kind of how it works. Okay, so let's see some of these examples, and they all don't match this directly, these first two. This is just trying to show you the relationship between the rates, creating a table, and so on and so forth. Okay, so let's move to the next example here. Okay, so in this example, we have Brian and Shanice, and they're both training for a bike race. Okay, so here's the bike race. And they want to compare who rides his or her bike at a faster rate. Okay, so interestingly enough, what happens is it says they use these bike apps to track their time and distance, but eventually you can see that one person charts their information on a table, and that's Brian. Maybe I'll circle his stuff in black. And then Shanice, hers is on a graph. So we actually got two different things to look at. So information in a table, information in a graph. And the idea is we need to compare the data to see, as the question was asking, who's going faster, okay? So they both start at 0, 0. That makes sense, 0, 0 here, and this is 0 and 0. Okay, so Brian's rate is 75 miles over 3 hours, okay? And if we look at Shanice, again, we look at 3 hours here, we work upwards, okay? And then we work across, like so. What we can see is she has gone 45 miles over 3 hours, okay? And so that's kind of a quick way to kind of approach these questions. If you can find matching data, then you can know who's going faster or what thing is cheaper, depending, again, on the question and the data being given to you. And when I say data, it's just the information in the question. Okay, so who's going faster? It's Brian, okay? At what rate does each person travel? Sorry, I need to put that in there. And it doesn't say unit rate, okay? So I could just put, for Brian, it's 75 miles over 3 hours, right? And then for Shanice, we could say it's 45 miles over 3 hours, okay? Because that is a rate, okay? And the explanation, and maybe I'll just verbalize it and maybe ask to you on the head puzzle. Basically, I found matching time, and then I compared the distances, and because Brian travels a further distance in the same amount of time, he must be going faster, okay? Now, of course, another way you could do this is from each person's data, you could actually do this with unit rates too, right? So I'm just gonna put this as a little side note. You could also do this with unit rates, okay? Because we can find a unit rate for each person, Brian and for Shanice. If I know he goes 25 miles or 75 miles in 3 hours, then I can figure out how fast he would go in 1 hour, okay? And if I do the division for Brian, it's gonna be 25 miles per hour, okay? And then for Shanice, if I do the same division of the rate, 45 miles divided by 3, that works out to 15 miles per hour. And oftentimes it's just easier to compare with unit rates. We might not get data which matches times like this or other things that we're trying to compare. But in this first question, it did work out pretty nice for us. Okay, and then the next thing it's going to ask you to do is make a new graph to show how the speed of Shanice would have to ride her bike in order to beat Brian. And I'm going to do that one for you because I think you can figure that out. But you do have to do this question, so do it. Okay, one last example. Okay, so in the last example, we got two people, Braylon and Tice, working at a department store, and they are paid by the hour, okay? And so the manager tells both the kids that they are both earning the same amount of money per hour, but Braylon and Tice don't agree. They each keep track of how much they've earned in order to determine if the manager is correct. And here's the data shown. So here we go. So if we look at this question, Braylon's amount paid is based on equation right here. Okay, so M equals 1050 multiplied by H. So just recall, when you have a number, even a decimal number, next to a variable, that means to multiply. Okay, so these, the quantity, whatever H is being multiplied by 10.50. And then the other person, Tice, okay, his payment is represented in a table. And here we go. We got 0, 3, 6, and then that's the time. And this is his money paid for each time slot. So I think Tice is the easiest one to work with because we're trying to go to 1 hour. So if he's getting paid $34.50 for 3 hours, all we need to do to figure out how much he gets in 1 hour is to divide 3 into $34.50. So I could do that pretty quick in here. Remember, keep track of the decimal place, and I'll put it in the same position here. 3 goes into 3 once, so that's a 3. Subtract 0, bring down the 4. 3 goes into 4 once, we get an 11. 4 minus 3 is 1. Bring down the 5. 3 goes into 15 5 times, so we get 11.5. But again, in the context of the question, that is $11.50. So this person, Tice or Teese or whatever I said initially, is making $11.50 per per hour. Now, the second person, Braylon, his amount is based on an equation. So M equals 1050 multiplied by H, okay? And so the number of hours, that is represented by H. So if we say $10.50 and we multiply it by 1, well, anything multiplied by 1 is itself, so it's $10.50. So that's how much he makes in 1 hour. So if we represent that as a rate, we could say his rate is $10.50 per hour. So how much does each person make? We've just done that in the A part. And now, is the manager correct? Well, one person makes $11.50. The other person makes $10.50. So the answer is no. And then we can explain, not just put ... based on our rate for each person. So we could say one person has a rate of $11.50 based on the table, and then the other person has a rate of $10.50 based on the equation. Okay, that's it. And all you have to do now is just the rest of the questions in this lesson number 19. Okay, thanks.